Hello dear students, so now today we would move ahead in this second chapter of class 10 science, that is acids, bases and salts. Okay, so we were discussing the chemical properties of acids and bases. So first we were discussing the chemical properties of all the acids, then later we would discuss the chemical properties of the bases also. So we have already discussed the chemical properties of the acids, isn't it? Yes. So now today let me tell you something more there. So we are just we are using this milk of magnesia. Okay, so what is this milk of magnesia? So now if you see, milk of magnesia is nothing but it's the magnesium oxide, that is MgO. So this MgO is known as the milk of magnesia. Okay, this MgO is known as milk of magnesia, and it is used as an antacids. Antacids means just when the amount of acid is more. Okay, so now to lower it down, we use this milk of magnesia to lower the level of acid there. Okay, let's say in the stomach, in your stomach, if you have you must have. So okay, so inside the stomach the hydrochloric acid is released inside the stomach. Okay, now if the amount of HCl is more inside your acid, okay, so it causes the acidity, isn't it? If the amount of acid is more there inside the amount of this hydrochloric acid is more there in your stomach, then it causes indigestion problem, isn't it? So to reduce or to remove this indigestion problem, we are using the antacids, means which would just lower down the level of hydrochloric acid there. So we are using the antacids as the medicine there. Okay, so and it is the milk of magnesia, and it is also known as the magnesium oxide. So this is nothing but the milk of magnesia. So we are using this as an antacids. Okay, so if the amount of acid is more there in your stomach, hydrochloric acid, so it causes indigestion problem. So to reduce this, to remove this problem, we are using this antacid magnesia, sorry, milk of magnesia we are using. Okay, now next very important that we are going to discuss is where to store the acids. Suppose the diluted, we have two types of acids we have already discussed there. Okay, we have the mineral acids which are very much corrosive in nature. Okay, some acids which are there normal in the fruits, these are not corrosive that too much, but the mineral acids which are there, they are very corrosive in nature. Mean they can like suppose the mineral acids, suppose it fall upon your skin, so it would burn your skin. Okay, so it can damage the cloth also, it can damage wood also. Okay, it can damage metal also, it can damage metal also. So that is why we can say that mineral acids are corrosive in nature. Mineral acids are corrosive in nature. Now what does this mean? It means that they cause severe burns on the skin and eat up the materials like cloth, wood and metal. So these metals are going to be eroded when you just use their acid. Okay, so now where to store the acid? If you have the mineral acid, where would you store this? Would you store this in metal container? No, because if you are storing the acid in the metal container, so this is going to corrode the metal container, this is going to react with the metal there, isn't it? And it would means it is going to react with the metal, it would corrode the metal, isn't it? So that is why we are not storing the mineral acids in the metal container. Okay, and in wood container also we cannot store it. Why? Because they are corrosive, they can corrode the wood also, they can burn it, isn't it? So that is why we can say that we are not using the metal containers for storing the mineral acids. Why? Because mineral acids are corrosive in nature. Okay, so where to store now? If you want to store the mineral acid, then you would store the mineral acid in glass bottles. So glass bottles are ideal for storing mineral acids. Why? Because they are inert. Glass bottles, the glass is not going to react with the acid, it is not reacting with the acid. Okay, so these glass bottles are ideal for containing what? Mineral acid, or storing the mineral acid. If you go to the shop where you have just acid, mineral acids, okay, so there you would find all the mineral acids which are there, all are there in the glass bottles, isn't it? You must have seen this. So that is why we just keep the mineral acids in the glass bottles. Okay, so just note it down, then we would move ahead, and then after we would be discussing the chemical properties of bases, because earlier we have discussed the chemical properties of acids. isn't it? Just note it down. Now these are the two properties which we would discuss today, the chemical properties of the bases. Okay, so the first one property is bases react with metal to give hydrogen. Okay, like we have discussed in case of acids also. Okay, so now in case of the bases also, if the bases are going to react with the metal, so they are going to give what? Hydrogen gas. So it can be asked in the question, what happens when the bases act with the react with the metal? So answer would be the bases react with the metal to give salt and hydrogen gas. Let me give you. You have base, and base react with acid. Sorry, this what is this? Metal. And what does it give? It gives salt and it gives hydrogen gas. Okay. So every time you would have to remember this hydrogen gas. Okay. So whenever what happens, it can be asked in the question in the examination. What happens when base react with metal? So answer would be when base react with metal, it gives salt and hydrogen gas. The question might be asked like this: which gas evolved? Which gas is evolved while base react with metal? So answer would be hydrogen gas, isn't it? So let me take some example. Let's say we have sodium hydroxide, and if it is going to react with, let's say, zinc is the metal, so it is going to form sodium zincate. Sodium zincate is what? Na2ZnO2. There is the sodium zincate, and then you are going to have hydrogen gas as well. Okay, now you have two sodium molecules, so you would write here 2. It is balanced, I think. Okay, so this is the equation. Whenever the base, this is sodium hydroxide, which is base, you have OH here, that is why it is base. So when bases react with metal, they are going to give salt. This is the salt, sodium zincate. We would call it sodium zincate. Okay, and hydrogen gas. Okay, now the next property, chemical property of the base is base react with acid to form salt and water. I think we have already done this in case of the acid also. In case of the acid, we have already done. Acid react with base to give salt and water. Similarly, base react with acid to give salt and water. Both are same, isn't it? Yes. So which reaction is this? Yes, this is the neutralization reaction, isn't it? Neutralization. This is the neutralization reaction, isn't it? Yes. So acids react with base to give salt and water. Similarly, bases react with acid to give salt and water. Similar. So this is again the example of the neutralization reaction. Okay. Now let me give you an example. Let's say you have NaOH and H2SO4. One is acid, one is base. So when these two are reacting, they are going to form what? They are going to form sodium sulfate, that is salt, and then they are going to form water, salt and water. Every time you would get salt and water. So this is what? This is the neutralization reaction, isn't it? Isn't it? Now, whenever the neutralization reaction happens, whenever the neutralization reaction occur, it would always occur with the emergence of heat. The heat is going to be evolved here. Some heat is going to be evolved here, isn't it? The heat is going to be evolved here. So how much heat evolve in case of the neutralization reaction? We have the example here. I would write here heat or energy, rather I would write here energy. Okay, energy released in, that you have to remember, neutralization reaction. Okay, so whenever any neutralization reaction is there, so some energy is going to be released. Some energy is going to be released. So how much energy is going to be released? The amount of energy is minus 57.1 kilojoule per mole. In other unit, if you want to write it, you can write it minus 13.7 kilocalorie per mole. Okay, so this is the energy released during the process of the neutralization reaction. Okay, so whenever the neutralization reaction is taking place, So the energy is going to be released, and the amount of energy is minus 57.1 kilojoule per mole, or you can say minus 13.7 kilocalorie per mole. This is in other unit, but both are same. So this much energy is going to be released in case of the neutralization reaction. Okay. Now if you want to write the change in heat, delta H, so the change in heat would be positive or negative? Just tell me, because it's the exothermic process, isn't it? So whenever you have the heat or the energy is releasing, then you would call such process as exothermic. Exothermic means heat is going to be released. Okay, so it's an exothermic process because heat is being released here. So whenever the heat is being released, so change in heat means delta H would be what? Negative. So always you would have to remember this. In case of neutralization reaction, you have the energy released, and how much energy is being released? This much can be asked in the exam. Okay, now and the question can be asked like, what would be the change in heat in case of the neutralization reaction? Either it is positive or negative. So answer would be negative, because it is what? It is exothermic process. So in every time in case of exothermic process means whenever the energy is going to be released, so all the time the change in heat would be negative. Like here I have written in negative. Written in negative or not? Yes. So why? Because this denote that yes, this is exothermic process. Heat is being released now here. Okay. So that is all for today. Would be discussing some other chemical properties of the bases in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.